Penicillin mechanism of action. The cell wall of gram-positive bacteria is composed mainly of thick layer of peptidoglycan, whereas the more stubborn gram-negative bacteria have an extra outer layer above the peptidoglycan layer. Peptidoglycans are composed of chains of amino sugars, such as NAMs or NAGs, that are cross-linked together by the short amino acid chains, such as alanine and glutamic acids. These amino acids are cross-linked together by the transpeptidase enzyme. To start their bacterial destructive effects, the beta-lactam antibiotics such as penicillin and cephalosporins have to pass through special barrel-shaped proteins known as porins that cross the outer layer of gram-negative bacteria. Then, penicillin must traverse the peptidoglycan and bind to specific proteins on external part of bacterial cell membrane called penicillin binding proteins or PBP. Binding to penicillin binding proteins activates penicillin antibiotics. Next, the active penicillin swims back to bind and inactivate the transpeptidase enzymes. The inactivation of transpeptidase enzyme results in the collapse of amino acid chains and damage of the peptidoglycan architecture. This leads to a series of reactions which end by massive destruction of cell wall and death of the bacteria. There are three major mechanisms for bacterial resistance to beta-lactam's antibiotics. Firstly, many bacteria have developed beta-lactamase enzymes that specifically bind to and inactivate the beta-lactam ring of these antibiotics. Therefore, beta-lactam's antibiotics become constrained and cannot attack the bacterial peptidoglycans. Secondly, some gram-negative bacteria close the porins and prevent antibiotics from reaching the peptidoglycans. Remember that there is no outer layer in the wall of the gram-positive bacteria. Finally, some bacteria develop mutations in the binding sites of the penicillin binding proteins, so penicillin is prevented from binding to them and remains inactive.